Welcome back. We have a question here which reads, a box of mass 9 kilograms lies on a rough horizontal surface. The coefficient of friction between the box and the surface is 0.3. Determine the magnitude of the applied force required to pull the box. Question 1, horizontally. Question 2, at an angle of 30 degrees above the horizontal. So we have a body of mass 9 kilograms that is resting on a rough horizontal surface. The question asks us to determine the force required. For the first instant, the force has to be horizontal to the surface, and for the second instance, the force has to be at an angle that is inclined to the horizontal. Let's try to determine the situation for the first case. We have the frictional force and we have the applied force P. And if we should complete the diagram, we have a normal force and we have the weight. The normal reaction is R and the weight is W. So because no acceleration is mentioned in the question, this body is most likely to be in limiting equilibrium. So for the first instance, as you can see, we have the applied force that is acting horizontal to the surface. The coefficient of friction given in the question is 0.3. So what we have to understand is, for the first instant, if this body is at limiting equilibrium, the applied force P is going to be equal to the frictional force. And we know that frictional force is equal to mu R. And what we have said about the value of R in a situation like this, if we do not have any other force, R will be equal to the weight. And we know that the weight is equal to mass times gravity. So therefore, the applied force is going to be mu mg. So we can use this to calculate the force required to pull the object along the horizontal surface if at all that applied force is horizontal. Coefficient of friction is 0.3. The mass of the object is 9 kilograms multiplied by gravity is 10. 0.3 times 9 times 10 is 27 newtons. So this is going to be the answer for the first question. Moving on to the second question, we want to know the situation if the applied force is acting at an angle of 30 degrees to the horizontal. So this is the angle, is 30 degrees. We have the applied force P here. To complete the diagram, we'll have the frictional force acting in the opposite direction, and we have the normal reaction R and the weight W. So if this body is to move along the horizontal surface, the horizontal component of P is what is going to be responsible to move the object along the horizontal surface. And that horizontal component is what we call Px. We also have the vertical component that we can demonstrate as Py. So this will make a triangle. And if we should draw that triangle out, we'll have the applied force P, the horizontal component of the applied force Px, and the vertical component of the applied force as Py, and this is the angle theta, which is 30 degrees. Using our trigonometric ratios, if we use sine theta is equal to opposite all over hypotenuse, then we'll have sine theta is equal to the opposite is py all over the hypotenuse is p. We've said that py is equal to p sine theta. And if we use cos theta, which is adjacent all over hypotenuse, so we'll have cos theta is equal to the adjacent is px all over the hypotenuse is p. So if we cross multiply, we'll have px is equal to p cos theta. So that is the horizontal and vertical component of the applied force P. Px is P cos theta and Py is P sine theta. So this is a vertical force here. And it is from this we've said that R plus Py must be equal to the weight. And for a situation like this, R is equal to W minus Py. Weight is mass times gravity minus Py is P sine theta. So that is how we have R is equal to mg minus P sine theta. Okay. If this body is in a state of limiting equilibrium, then the horizontal component of the applied force P cos theta must be equal to the frictional force. So P cos theta is equal to mu R, and P cos theta is equal to mu into R is mg minus P sine theta. We have already derived R, okay? And it is mg minus P sine theta. So that is P cos theta is equal to mu mg minus mu P sine theta when we expand. So we can have P cos theta plus mu P sine theta is equal to mu mg. If I factorize P out, that will be P into cos theta plus mu sine theta is equal to mu mg. Then I can divide both sides by cos theta plus mu sine theta. This will cancel this. So P is equal to mu mg all over cos theta plus mu sine theta. So the applied force will be, the coefficient of friction is 0.3, the mass is 9 kilograms, acceleration due to gravity is 10 all over cos 30 because the angle is 30 degrees plus the coefficient of friction is 0.3, then sine 30. So we will have 0.3 times 9 times 10 is 27 all over cos 30 is 0.8660 plus 0.3 sine 30 is 0.15. So that will be 27 all over 0.8660 plus 0.15 is 1.016. So 27 divided by 1.016 is 26.6 newtons as the answer. And that is all for today. Thank you very much for watching this video. If you find it helpful, please like the video. You can share it as well. Do not forget to subscribe to our channel. In our next video, we will solve problems that involves acceleration for a body on a horizontal surface with an inclined applied force.